Hello there. So we're answering this question about the pressure. So here we have just some kind of lift, a hydraulic lift. Here we have this piston X and piston Y. And of course, whatever we're gonna do on piston X is going to affect piston Y this way. So let's get rid of this and this. So the first question here is saying that they want us to calculate the difference in pressure at from this point to this point, the bottom of piston X and the bottom of the oil. So basically they're giving us, like here, they're giving us the height difference, which means that we can use that. And so we have the height difference only, and they also mentioned the density. These things can help you know which type of, which formula that you're going to use. P has two formulas. Either P is equal to F over A, but we don't have F here. We do have A though. But it can be also G, not mg, it's rho G. It's rho GH. So here we have the density, and that's why we're going to go with this one. And also we have the height. So rho is 820 times G, which is 10, times H, which is 57. And don't forget to convert it into what? Into meter. So -2. And then I don't know the answer. Let me try to calculate it. And it's gonna be 4700. 4700 is 4,700 Pascal. That's the pressure in the first one. I hope it's clear. So we're gonna go to B, which is, they're saying like if we add some kind of a mass here that is 24 kilogram. If you add a mass over the piston, of course, you're going to be adding more pressure on the oil here, which means that this piston is going to move downward and blah, blah, blah. This is going to affect the other piston, which will make it go up. So we have a net force that is going upwards here because of the pressure on the piston X that is due to the extra mass. So the question here is calculate the weight. Oh, that's a very cute question. Calculate just the weight of the mass. Because why? Because what we care about when we're talking about pressure is the force. We're not concerned about the mass itself, but the force acting on that piston. So the weight is a type of force. So it is mg, right? So m is equal to 24. It's given to us here, and it's in kilogram. Everything is nice. Then times 10, which means that it is Newton. Very ugly in. Yep. So they're asking about the unit as well. So it's a weight, it's a force. So of course we're gonna be using Newton. And then the other question here is calculate the extra pressure on the oil due to this mass. So we know that the mass has a weight, which is F of what? 240 Newton, right? So now they're asking about the extra pressure because of this mass, or the force of this mass. So it is going to be P F over A. How did I know that is F, not rho GH? Because here, what's given to us is the force. And also, we know, it's so crowded. And we know We can just leave the mass. Yeah, better. So we know that the area is 1.2 meter squared, and it's given to us in the diagram. So we're gonna make use of this. It is 240 over 1.2, and it's in meters squared, so we're good. And you just use your calculator. Yeah, it's easy. It is 200 Pascal. This is the extra pressure. I hope it's clear. Let's go to the next one. Number 3 here. The oil transfers the same extra pressure to piston Y, as I mentioned here. So it is like whatever happened in X, it's going to be affecting piston Y, but the other way. Like here, you see, this one is acting, Bismillah, acting with this force. Let me just choose this one again. So this is the pressure because, or due to the extra mass, which means that we have extra weight, extra force on this small area, more pressure, since the pressure is a force over the area. And then this pressure is going to be transferred till this point here. It's going to be impacting this area. And we know that this is one of the principles of the pressure, or in fluids. Pressure here and pressure here are equal. P here and P here, they're equal. The thing is, if they are equal, it means that the A or the F, or both of them actually, they're going to be changing. So here we have F over A, F1, Fx, Ax, and here we have Fy over Ay. So the pressure in both of them is equal, since it is due to this, the extra pressure at least, due to this mass. And now we're gonna see the oil transfers. Yeah, so calculate the force acting upward on the piston Y due to the extra pressure. We know the extra pressure is equal to what? The extra pressure is equal to 200 from here, 200 Pascal. This is the extra pressure. And we know that this, like pressure generally, is F over A. And in this case, A is equal to what? In piston Y. We want to find the force acting in piston Y. In piston Y, the area is 4.8 square meter. And so what is the force? We're looking for the force. And this is how you do it. You will find F is equal to 200 times 1.8, which will be 960 Newton. It is a force, so it is Newton. I hope it's clear until here. If there's anything that's not clear, you can ask me. Now let's go to C. Piston Y starts at rest, so it was at rest, and then piston X did some kind of add some kind of drama, and now piston Y is moving slowly, rising slowly, and then it is at rest again. So this is a little bit of a journey here. State how the following energy stores have changed from before the motion to after the motion is complete. Now starting with the gravitational potential energy of piston X. Now when piston Y is rising, piston X is what? It is going down, which means that its height is less than before. And we know that the gravitational potential energy is all about the height. If the height is decreasing, it means that the energy, the gravitational potential energy, is decreasing as well. So it decreases. increase. So the other one here is asking about the gravitational potential energy of piston Y. Now piston X, we know that it's going down. Piston Y, we know that it's going up. So the other one is going to increase, right? Because it is getting higher. And the word rise is here, is giving you the hint. So of course, the higher it is, the more the gravitational potential energy. The chemical energy, well, we didn't do anything regarding that. So there's no change here. Why? There's no change here. No change. We didn't touch you, bro. So the kinetic energy of the piston Y is, okay. Now the kinetic energy at the beginning said it is at rest is 0, and then it rises slowly, so there is kinetic energy, but rising like it is moving, so there is a kinetic increase in kinetic energy. However, they're saying like it comes at to rest, which means that at the end it is 0, or like they're asking for change, so no change. It is going to be again 0. I think that is the end of the question. I hope it is clear. Bye.